In this video, I'm going to show you how to use Stata to generate descriptive statistics. So what we're going to do is just to launch Stata to start with, and we're going to open up the tree swallow data set that we have been using. So this data set is available for you to download on the biology department website. Just navigate to statistics and scientific writing, and you can find a copy of the tree swallow data set. I encourage you to load the data set into your copy of Stata and follow along. So we'll open that up. We can see the command was issued here and it's now cataloged in our review panel. So we know we have the data uploaded. I'm going to take a quick look at what's in the data set just as to jog my memory. So I'm going to issue the describe command, and I don't even have to type describe. I can just type DESC, and I remember now that I have three variables. There's one variable for area, that's a text variable or a string variable, and then there are two numeric variables, weight in grams and wing length in centimeters. I'm going to be interested in knowing what the typical value of the weight is of these 80 tree swallows that were captured at a banding station. To do that, I'm going to go up to this statistics window or statistics menu, choose summaries, tables, and tests, move over to summary and descriptive stats, and then finally summary statistics right there. I have to choose now what variable I'm interested in, so I'm going to say that I want to know about weight, and I'm going to click OK. And now Stata has given me some simple descriptive statistics. Of those 80 tree swallows, they have a collective mean of 22.15 grams, and the standard deviation is a measure of the variability of that population, and so the standard deviation is 3.9. The highest value was 35, so that's the fattest bird, and the leanest bird only weighed 16 grams. Notice again that anytime we issue a command, even if we do it with the pull-down menus up here, it's going to generate a command line entry that is going to be ultimately cataloged. And what I'm going to do is to use this to take a look at what the wing lengths are like. And I've got my basic command there, but this time I'm going to go over and refresh my memory in the variables window here about what the other variable is called, and I see that it is in fact called wing length centimeters. And now I've generated similar descriptive statistics for wing length, that the mean is 11.45 and the standard deviation is 2.2 or so, and the minimum and maximum are shown right there. And of course, I don't have to do these things sequentially, so what I could also do is to say, well, I want to do both at once. And Stata, unfortunately, is case sensitive. So if I typed little w-e-i-g-h-t, which I almost did, it would not be recognized. So there, in one command, I've generated both the wing length and the weight variables that are right there in a nice little table. So that's very, very handy. Stata will calculate more sophisticated measurements for you as well, and let's take a look at that. Let's go up to statistics, get back to summary statistics over here, and this time I'm going to select both of the variables again, so I'm going to put a space in there, and I'm going to click wing length. So I'm doing the same thing that I did by just typing over here using the review panel a moment ago. This time what I'm going to do is to pick display additional statistics. So there we hit OK. And now let's just look at weight to start with. Over here we have the mean and the standard deviation that we saw earlier, but we also have another measurement called the variance. It's related to the standard deviation, and there are two measurements, skewness and kurtosis, that relate to the distribution of the data. We also have here on the left the medians for the data, and the 50% median, or what we would call the typical median, is the value at which exactly half of the values are below it and half of the values are above it. So, and we see that the median value, one measure of the typical tree swallow weight here is 21, it's a little bit less than the typical value as measured by mean, which is a little more than 22. These other medians can be useful as well. The 25% median is the value at which 25% of the values are below 19 and 75% are above 19. And I've generated the same sort of data for wing length that you can see right here. Let's go back to the data browser to take a look at our data. And when we do that, you can see that, in fact, we have tree swallows that were banded in 3 different states. So we have Vermont, Maine, and Alaska. And it might be interesting to see if there are differences among the 3 states. So we're going to go back to the results window here. And I'm going to go back up to the statistics window here and get over to the summary statistics. And this time what I'm going to do is to ask data to generate, we're just going to generate the standard statistics right here, but what I'm going to do is to ask data to do it by using the state in which the bird was banded. So what I needed to do was to click this box here that says repeat command by groups. I'm going to go down and pick area, like so, and say OK. And now what I have are the values for the Alaskan birds, and so you can see that the mean weight of those birds, 26.4 grams, quite a bit heavier than the Maine birds, which weighed about 20.1 grams, and the Vermont birds, which were at 19.8 or so. So that's a very simple way to partition your data according to one of your classification variables or one of your string variables.